I'm going to be producing some videos that show you how to make some repairs on the DG-3 and the DG-1 series of ozone generators. I've got a couple of units here. We're going to open them up and show you how to repair them. There's some screws around the top. I've already got those opened up. Once you open this up, there are a couple of this little ribbon cable. Just make sure the unit's unplugged. Unplug that ribbon cable and this little display cable, and then you've got access to the unit. Now, I've already determined that the circuit board in here is not working. One of the things that you can see that may have led to some of these failures, this coloring on these elbows, this brown coloring, indicates that there's been quite a bit of heat in the cabinet. And then another thing, if you could just kind of show way down in here, you see these little plastic drips on there, indicate that this got quite warm, and it's likely that this fan quit working. So I want to check that out too once I get the board replaced. But the fan maybe wasn't cooling it down. It got overheated and overdriven, and this circuit board quit working. So I just want to show how to replace this circuit board. I've removed some screws here. A couple of other things I want to show you in here. This is a flow sensor. The oxygen is coming in this tube here, and it detects a differential of pressure. It works best if you can get a little needle, those pliers between that rubber, and just kind of gently pry these off. If you try to just pull them straight off, you end up risking damaging the board. I probably should have done that before I took these screws out, but just wiggle it back and forth a little bit, get it over the edge, and that'll pop off. Now one more screw here. I guess I did get them all off. This here's the power coming in, your 110 volts. That's plugged into your power in. And this other plug, grab the two little ears on the side, pull this plug up. This is the high voltage transformer. So the inverter board here is making a high frequency, high voltage, or not high frequency signal for this transformer. Then your high voltage is feeding into your ozone cells. This board isn't showing too much indication of problems other than the black. You can just see that things got really hot in here, and some of the flux there is melting off, and this capacitor is bulged up a little bit as well, but when running it doesn't do anything. You can see also here, these are the transistors that's switching the signal that may have gotten overheated. This board needs to be replaced. The fact that this is discolored, all these are kind of clues that it just got too hot in here. So I'm going to replace that board. Okay, so I'm continuing the video here of replacing some components on a VMUS DG-3. Just before we go any further, I'm going to just show on here. This here tells you what unit we're working on. The serial number is valuable. Sometimes changes are made over time, and it's good to know the serial number. This is a DG-3. DG stands for double glass. It's referring to the type of quartz dielectric that's being used. This particular unit, the circuit board here, they're programmed to work with specific type cells. Since this is a DG-3, we want to make sure that the board is the correct board for this. It's checked off for DG-3. The new one that I've got here is checked off for a DG-3. So we're going to replace this. Get it screwed on there first. each of these has got a little lock washer. There we go, steel one over here. Just one other thing while we're working in here, sometimes you'll see these little black flecks. They will crack off from this transformer. This is like a powdered iron, and it's quite brittle, and sometimes in transportation these things get banged around quite a bit, and the heavy transformer wants to jog around, and little pieces will chip off the bottom. If a few little flecks come off, it's nothing to worry about, but you want to just get them out of the enclosure so they don't interfere with any part. We want to reconnect these flow sensor. This tubing is pretty soft and squishy, so they go on fairly easy. Alright, the fan plugs into this little plug here. And our power coming in to the power pin. And finally the transformer. Okay, in the next video I want to show you how to replace these dielectrics as well. This one isn't cracked, but for now I'm going to plug this back in and we'll see where we are at. Put this ribbon cable in the display, and we'll put some power to it. Let's see here. Okay, so I'm going to put some power to this unit, and you notice as soon as I put power to it that this will light up with kind of a dim reading. If I press the on switch, it gets brighter, and it also is telling you that there's no flow. And I can set the amount of power that the ozone generator will make. Right now it's not turning on because there's no flow. So I threaded in this barb connector on the oxygen input just so I can test this. I want to put a little puff of air into it to verify that the flow is working, that the ozone generator will start up. At the same time, this fan should turn on. So let's see what happens here. Okay, so it looks like it's turning on, but I don't hear anything, and the fan is not turning on. So we've got something else. I smell some ozone. So usually you can hear a little bit of a high-pitched whine, but I'm smelling ozone here now, so that means that ozone generator is working. Let me just verify one other test. You can pause it. Okay, one other thing we can do to verify the operation of the ozone generator is a clamp-on amp meter. We're going to set it to 40 amps and clamp it on either the white or this black wire. I'll try to do it so that we can see it on the camera here. I may need another. Okay, so right now it's reading like 0 amps in. Yeah, can you see the zeros on there? All right. Okay, we can see the blue LED. That's indicating that your inverter board's working. We can see the increase in power. I have this set at the 4th level here, so it's using a little less than half of its total power. If I turn that up, then it's going to draw up to like 3 amps or so. So everything seems like it's working, but we did note that the fan is not turning on. And that's probably the root of the problem, why everything else quit working, so we need to replace this fan. We'll do that in the next little section here.
Do I stop it?
Yep. Okay, so we've determined that this fan is not turning on when the ozone generator kicks on, so I need to replace it. Want to make sure we've got a 24-volt fan. I'll take this one out, and looking at it, this is the same type of fan. You want to get something that's going to be equivalent. If it draws too much power, we don't want to overdrive the board. If it's too small, we need to get enough airflow through here. One thing, unfortunately, we don't have the little plug at the end. So in a pinch, probably the easiest way to solve that problem is to use a couple little tiny wire nuts. So that's what I'm going to do, but let's get this fan out of here a minute. Okay, so it's, yeah, you can see some, looks like plastic dripping on there, but it just got so hot, these generators got so hot that there was some sealant or something in there that melted out of it and dripped down on the fan. Otherwise, everything looks fine with the fan. It does look like, I guess that's that plastic material that dripped down from here. So sometimes if you get a little bit of water or something on the fan, I don't see indications of much damage, but you know, if you're inspecting your generators, fan is going to be pretty important. If you see one that's not operating, we want to make sure we get that replaced so that it keeps things cool and doesn't result in a bunch of other problems. Let's see, which way did this go? I think it's blowing in, so we've got it orientated right. Get these parts out of here. There are little arrows there to tell you which way the air is blowing. Alright, let me just kind of show it down there to see what we're dealing with. Once we got them in, tighten it pretty nice. If you need to hold them, not to get tight. Too much, then you end up cracking the plastic. So just enough to. Okay, so like I said, on the old one here, I don't have the nice little plug on the end, so I am just going to cut this one off and use a little wire nut on there. Okay, so we just want to make sure that these wire nuts don't get in the way of the fan. I guess we didn't have a fan guard or anything on this side. This only plugs in one way. Alright, so now we got our fan in. And now we will try this again. Plug in this ribbon cable. Power. Just light up, put a puff of air through it. Hopefully we hear the little fan start to buzz. Okay, so my fan wasn't running and I'm trying to figure this out, and it looks like this plug will go in two different ways. I think I had it on backwards. So there's a little clip on this side that's got a clip on the, so So we're going to turn that around, and I'll just leave this cover open and give it a pop. There we go. Kind of noisy. Okay, I think I understand the problem here. So there's a little bit of that glue was down, and when it's pulled up tight, it's running into that. So we're going to try to clean that off. Fortunately, that's might be able to get at it from the inside here. Yeah. Let's see. I've got a different screwdriver I can use as a. Let's see here. You can see this dab of glue here on the inside, and one option, I'm just going to pry this out just slightly so that it's not hitting that fan. Okay, let's see if that helps. You can go on the other side again. Alright, let's try it one more time here. Okay, that's better. We'll zip tie or do something, but maybe just a couple of wraps around here will prevent that from getting where it doesn't belong. Okay, now the last thing that I wanted to show, with these cells, sometimes in transportation when things are really rough, these will move back and forth, and the tubing on here is FEP tubing. It has to be rather, it's a rigid type tubing. It holds up really good to ozone. One fault is that it's quite rigid, and it puts too much pressure on these glass nipples, and we see sometimes they get cracked off. And I'll show you how you can take those off and replace tubing if needed. We do need some heat. A small torch works really well for that. You just heat up and gently heat up this plastic here. It can handle quite a bit of heat. Try to do it even and not put too much heat on the glass itself. Once you've got it heated up, they usually will slide off fairly easy if you use a little bit of leverage. Try not to put too much pressure on the glass. If it doesn't come with a gentle nudge, there we go. Alright, so as it cools and contracts, it makes a really tight seal on that nipple. The new tubing, this is FEP tubing. It's 1/4 inch inside diameter, 3/8 outside, so it's rather thick. And to get it on there, it just doesn't fit. So the best option is to heat that up and expand it a little bit. To replace these, if they would crack, these heat sinks come off. And these, because they got so hot, I think, and they've got some Loctite on there to keep them from coming loose. They seem rather tight. The thing is, when we're putting them back on, you have to be really careful that you don't over tighten and crush that glass. It's rather fragile. These are coming out kind of hard because of the Loctite on there. and because I think these got quite hot and baked some of that plastic inside there. Okay, so we got the screws out. Yeah, this is just got really hot, and it melted some of that, it's really not glue, but whatever is used. This is like an aluminum tape over the top, and then there's like an aluminum, it's a heat sink material. You take both of them off, and this whole tube will come out and can be replaced. There's a little bit of a gap, and it's smart to put just a little dab of like paste, heat sink paste, so that you've got good contact. And when you screw this back down, you have to be really careful that you don't overdo it. Because it doesn't take much to crush them. The only time I see these, I haven't seen these fall apart, but sometimes in transportation, some screws can come loose. But once they're installed, you just want to make sure it's just tight enough to hold this snug. And if you've got some paste in there, that'll help make the contact, but not tight at all, barely finger tight. Okay, a new one of those. I'll grab one of those and show you. They get shipped in this little protective container. And this is your high voltage connection. That's going to come out of the top here. So when you're replacing that, you want to put it in there, without tightening things down too tight. When we want to hook this tube back up, try to give a little bit of flexing between them so that they don't put a lot of tension on there. Once you got everything in place, just a little bit more, snug these down. Having a little bit of the heat transfer paste in between helps keep these cool. Since this looks like it got really hot, there's probably a risk that that's going to crack prematurely. So what we're going to do is replace this whole section here. I'm going to heat this up, see if we can get that off. All right. With these barb connectors, we have to make sure that they are Kynar. On the newer units, the manufacturer has switched to glass elbows, and the reason for that is the glass is going to be the most resistant to ozone. They're going to hold up the longest. The problem is they're fragile to work with, but this is what we've got to work with here, so I'm going to replace these. And I think what I'll do, we can try removing the tubing, or we can use new tubing. As long as this tubing is in decent shape, the Kynar material is very resistant to cracking, but if I have to grab it inside here, I might. Okay. problem is I kind of damaged that edge there just a little bit. Okay, while it's still warm, I'm just going to stick the new one on there. Makes it nice. The nice thing about reusing the tubing, it is kind of pre-formed, so it fits nice. If you do need to cut new sections, this tubing does seem to be just a little bit different than this FEP tubing. But yeah, like you saw earlier, it is a bit tricky to work with. If you get it too hot, then it wants to scrunch up. If you spray this with just a little bit of soapy water, and just another little tip, we're working with ozone. Soapy water is really useful for finding ozone leaks. If your system's under a little bit of pressure, even if it's just, you can keep the generator off, but run some oxygen through and spray the connections. If they've got a little tiny leak, it'll make little bubbles. A real big leak is harder to find because it doesn't make the bubbles, but a very useful tool. We're going to use it here to make this just a little bit more slippery and easy for this to slide on. Just going to heat the end up first a little bit to expand it so that it'll go over the edge. Once I've got that, heat this up just a little bit more. And I'm going to spray this just a little bit of soapy water. See if I can't get that to slide on easier. There. I need to heat that up just a little bit more. Okay, and yeah, it does take a little bit of force. You don't want to do it too much though, but once it shrinks on there, it makes a very tight seal. So I think what I'm going to do, since I've got that on there, we're going to cut this to size and use that in place of this one here. So it's about that long. Remove this one. When I had to pull it off, I damaged that edge a little bit, so let's take this one off. You have to be careful you don't heat it up too much because these barbs will start to melt and you don't have a very good fitting there. Oh, I see, I did that backwards. I need the really short one up on top. So I need one this size. Now I've got to be a little bit careful I don't put too much stress on this and crack the nipple off. I think this is the one that I damaged the edge. Could have warmed that one up a little bit more. All right, I'm going to slide this on the bottom. And you can see that there's, I don't want to put a whole lot of tension and risk cracking that nipple off, so I want to put a little bit of heat on this section so that it's not so stiff and it bends easier. And I don't risk breaking that. Alright, now make that just a little bit warmer so it'll slide in. Just need it just over the edge. Alright, looks like we've got it. Slide this one on just a little bit further because I don't want so much tension on these nipples when it gets transferred. Alright, the newer ones do have a little bit better support. The problem is in transportation these wiggle around, and if somebody throws it, that union from one side to the other can crack this dielectric. Yeah, so there have been some improvements made to stabilize that. Alright, so I think this unit is good to go. Got it plugged in, put a little bit of air through it. Oh, I don't have it plugged in, I gotta hook this up. Okay, plug the unit in, see it's dim. Put it wherever setting you want it. Like we're making ozone. It smells some ozone, so I think we're good on that one. All right, that concludes repair on this particular unit.